Welcome to Open Cloud Platform K-PaaS Specialist Training. Objectives for Day 1. Trainee will be able to understand the fundamental attributes of cloud computing technology, its evolution, and the latest trends. Also understand the types and characteristics that distinguish cloud computing services. Third objective for Day 1 is to be able to understand the concepts of cloud-native applications and key concepts such as MSA, container, DevOps, and CI/CD. Lastly, the development background, architecture of K-PaaS, and the features of the latest version should be understood. For detailed contents for Chapter 1 lecture, you can refer to the table of contents shown. Section 1. Understanding Cloud. Part 1. Basics of Cloud. Cloud computing is a network-based computing technology that aggregates computing resources in a large number of data centers and then virtually separates them into individual user needs and provides them through the information and communication network. In short, cloud computing is the provision of computer services such as servers, storage, databases, networking, and software over the Internet. In the traditional legacy environment, the on-premises environment, if a user needed a server or needed storage, they had to purchase the server or storage equipment themselves. However, with cloud computing, the aforementioned tasks are minimized, and the user can use the desired resources in the already configured cloud environment at the same time as the request. These benefits are one of the reasons why the cloud market has become so large today. Next, let's look at the 5 characteristics of cloud computing. First, on-demand self-service. With cloud services, you don't have to interact directly with the provider, but instead can access services through your own personalized management screen. When you use an application in an on-premises environment, you purchase the application program from the market provider and receive a storage device with the installation file, or download the installation file and install it. However, when you use a cloud-based application, you can select and use the service directly from the management screen. Second, support for broad network access. As explained earlier, the cloud is a network-based service, so you can access and use the service not only through a computer, but also through various devices with network access, such as portable devices, smart TVs, etc. Third, resource sharing. As an example, think of a cloud storage service. Users can use storage space provided by the provider in the cloud. This storage space is the computing resources of the provider, and the user does not know the exact location of the resources they use. In other words, the cloud service is used as a form of sharing the computing resources of the provider with multiple users. Fourth, expedite scalability. Users can scale up or down as needed. When purchasing or renting a traditional physical server computer and you want to add a faster CPU, or more RAM, or if you want to lower the specifications, you need to purchase additional equipment to increase performance or replace the computer itself. However, when renting a cloud server, you can specify the CPU, core, or memory and receive a virtualized VM, so you can replace the CPU of the server, computer, or replace the amount of RAM and memory as needed. Therefore, cloud servers are free to scale up or down compared to the method of renting a physical server. Finally, cloud computing is a measurable service. Cloud services are pay-as-you-go services, meaning you pay for what you use. In other words, the cloud service monitors how much you use its resources and charges you for what you use based on that monitoring information. Part 2. Evolution of Clouds. The picture in the textbook shows the major milestones in the evolution of cloud computing. Starting in 2000, cloud computing as we typically think of it began in earnest. The first generation of clouds is from 2001 to 2009, with centralized clouds that rely on data centers as the leader, and the cloud market begins to be created. Starting in 2006, Amazon began releasing its cloud computing service EC2, and cloud services really took off. This was the time when database services became available in the cloud and the Dropbox concept became popular. The period from 2010 to 2015 can be considered the second generation of cloud. The second generation was characterized by the rapid growth of the cloud industry, which led to an abundance of services and increased competition among providers. The parts used by enterprises start to become commercially available services. Cloud foundries are created to create open-source platforms, and the release of containerized services in Docker in 2013 further accelerates the development of microservices. In 2015, Google and the Linux Foundation partnered to create the Cloud Native Computing Foundation, and Kubernetes was born. The cloud of 2017 and beyond builds on the advances of the past. Between the first and second generation of clouds, cloud computing begins to gain traction when it comes to external processing and heterogeneous cloud resources. The next generation of clouds will see the growing influence of edge computing to reduce latency caused by centralized clouds from 2020 onwards. And most recently, the use of artificial intelligence and machine learning is rapidly advancing and spreading, with the global cloud market set to exceed $370 billion in 2022, and the beta release of Microsoft ChatGPT. Going forward, cloud computing technology is expected to evolve even more rapidly. Next, we'll discuss edge computing technologies that have begun to evolve since 2020. Edge computing is a computing technology that helps accelerate the flow of data by processing it in real time, at or near where it happens. With the advent of the Internet of Things, billions of devices have been connected to the Internet and started to be used. As a result, there is a limitation that communication signals are delayed when excessive network traffic occurs. Edge computing has emerged as a technology to compensate for this. Edge computing has the advantage that data is not processed on a central server, but rather at the very end of the computing system, close to the terminal device, so that data analysis and processing can be shared, enabling real-time signal processing. Edge computing technology is currently being used in self-driving cars, AR and VR, industrial sites, robots, and drone devices. Part 3. Cloud-based major enterprises. The illustrations in the textbook are companies with cloud-based businesses. You can check out the cloud-native landscape on the source link shown at the bottom of the textbook. The Cloud Native Landscape is a resource that is updated periodically by the Cloud Native Computing Foundation. It is a resource for finding out which products from which companies to choose and use in combination to build cloud-based applications and for keeping up with trends and developments in the cloud industry. Part 4. Cloud Trends. The cloud market is growing rapidly and becoming a mainstream part of enterprise IT infrastructure. The graphs you see in the textbook show projections for the global and domestic cloud, services, and infrastructure markets. According to a report by Global IT Advisory from Gartner on 2023, the global public cloud services sales forecast for 2022 is $491 billion. It is expected to grow to $593.3 billion in 2023 and $724.6 billion in 2024. By type, SaaS accounts for the largest share of the cloud market, followed by IaaS and then PaaS. The domestic public cloud services market is expected to reach about 5.9 trillion by 2022 and grow to about 8.5 trillion by 2024. Global and domestic cloud service sales are steadily increasing, and we predict that the scale will continue to grow in the future. Let's take a closer look at the domestic cloud market trends. IDC Korea, an IT market analysis and consulting firm, has predicted that the domestic public cloud services market will be worth about 4.25 trillion Korean won in 2023 and will reach more than 7 trillion Korean won by 2027. This is due to the fact that domestic enterprises are continuously expanding to cloud workloads, and financial companies in particular will continue to see a solid growth as they expand their cloud environments or incorporate them into next-generation systems. The graph on the right is from a report released in August 2023, which predicted that the domestic cloud IT infrastructure market will grow at a compound annual growth rate of 8.8% over 5 years, reaching a market size of 3.847 trillion won in 2027. The current PaaS market is a hodgepodge of companies. Existing SaaS providers have pre-made platforms to organize their SaaS, and sometimes these platforms are refined and released as PaaS, or existing software or hardware companies such as Microsoft and IBM develop PaaS platforms to increase their share of software or hardware and enter the PaaS market, or companies such as Google and Amazon, which are internet service providers, enter the PaaS market with the platforms they use. However, as various companies enter the PaaS market, the problem is that if you use a specific service, you can only continue to use that service. When SaaS companies deploy new applications by issuing commands to PaaS, there is a high probability that there will be a dependency on SaaS, and there will be a problem of discontinuation of PaaS support or unexpected increase in cost. Therefore, PaaS using open source has been in the spotlight, and the proportion of use is gradually increasing. Next, we'll look at cloud computing trends over the last 2 years. First, we'll look at the top 5 cloud computing trends for year 2022. These trends are based on an article published annually by Forbes, an American publishing and media company. Let's dive into them in order. First, cloud-native technologies will become mainstream. More than 85% of major organizations will embrace clouds-first principles by 2025, and more than 65% of new digital workloads will be deployed on cloud-native platforms. Container usage will increase, with Kubernetes containers and orchestration-based platforms becoming mainstream, and containers will grow in usage and development from 42% to over 50%. Second, increased use of low and no code. Low code and no code are areas where all cloud companies are putting resources to expand support. The use of LCMC is becoming more common for advanced automation capabilities and artificial intelligence that complement developers, and we predict that LCMC technology utilization will rise from 25% in 2020 to 70% in 2025. Third, potential growth opportunities for SASE. The use of SASE will expand to ensure that users can access anytime, anywhere, because most of the traffic from edge computing locations will never go to the corporate data center. This means providing security at the session itself, rather than sending all traffic to cryptographic equipment inside the data center. Gartner has predicted that by year 2025, more than 50% of major organizations will have a strategy for adopting SASE. Fourth, the utilization of hybrid clouds offered by public cloud companies will increase. Hybrid cloud enables the integration of on-premises and public cloud computing resources and allows organizations to choose to deploy resources on-premises and from multiple public cloud companies. In the past, hybrid cloud has been driven by on-premises technology vendors, but in the future, we predict that it will be driven by public cloud companies. Fifth, cloud environmental and ESG sustainability efforts will expand. As the climate change crisis continues, there will be a growing movement toward environmental, social, and governance, or in ESG, in cloud computing. In addition to these 5, Forbes predicted the rise of the serverless cloud in 2022, saying that artificial intelligence will be intertwined with the cloud so that their development and evolution will drive each other. Without further ado, let's take a look at Forbes' top 5 cloud computing trends for 2023. First, cloud security and resiliency investments will increase. The migration to the cloud offers tremendous opportunity, efficiency, and convenience, but it also exposes organizations to a new range of cybersecurity threats. With more laws governing how companies store and use personal data, the risk of paying fines and losing customer trust will increase, making building resilience an investment priority. Increased use of AI and predictive technologies designed to detect threats before they occur, and the use of security providers as a managed service will grow. Second, multi-cloud demand will increase. If 2022 was the year of hybrid cloud, 2023 will be the year of multi-cloud. Adopting multi-cloud means moving away from the risky strategy of being overly locked into building apps and processes on a specific platform. The growing demand for containerized apps makes it possible to quickly port apps to new platforms as service levels change or as cost-effective solutions are offered by multiple companies. In 2020, 70% of enterprises were locked into a single cloud service provider. By 23, 84% of mid-sized businesses will adopt a multi-cloud strategy. Third, in 2023, cloud-based AI and machine learning will be the trend. Most AI and machine learning services are cloud-based because few companies can afford to build their own AI infrastructure. Data collection and algorithm training require huge amounts of computing power and storage space, which is usually cost-effective to rent as a service. Cloud service companies are increasingly relying on AI in many areas, including managing vast distributed networks, regulating power and cooling systems in data centers, and enhancing cybersecurity solutions to keep data safe. In 2023, we'll see continued innovation in this space as the largest cloud service providers apply their own AI technologies. Fourth, the trend toward low-code and no-code based services will continue in the following years. Tools and platforms that enable anyone to create apps without using code and use data to solve problems are growing in popularity. The category of low-code and no-code solutions includes tools for building websites and web apps and designing most of the digital solutions your business needs. Low-code and no-code solutions can also be used to create AI-powered apps, significantly lowering the barrier to entry for AI and machine learning-based businesses. Both low-code and no-code solutions are cloud-based, so users can take advantage of the services without having to own a powerful computing infrastructure. Finally, in 2023, we expect to see innovation and advancements in cloud-based gaming. While still nascent, major cloud services companies are offering streaming video game services. The problem with streaming video games is that they require more bandwidth than music or video, so users must have access to high-quality, high-speed internet. When 5G and other ultra-high-speed networking technologies are released in 2023, this problem will be solved, allowing cloud gaming to innovate and evolve. We strongly predict that cloud gaming will be the killer app in 5G. So there you have the latest cloud industry trends. This concludes Section 1, Understanding Cloud. In Section 2, you'll learn about understanding cloud models and characteristics.